Yeah, but what I will suggest you is recording is fine. You take I will these things pictures that we'll be writing, notes, right? That you save it, okay? And after the class, you make your own notes because last
Yes, sir.
moment that is what will help you. Okay, the recording and all, like you will not have that much time to go through the recordings, last moment. Understood?
Okay, so how do I take, like, should I take screenshots?
Yeah, you take screenshots. If you are not able to, I will also save it. And after class, but you write in your notebook. Okay, don't keep it as it is. So after
So
the
right now?
right now, you just listen to me because if you want to write, then you will not be able to focus in the class. So anyway, I'll
Okay,
be
yeah.
writing everything here. But just after, immediately after class, you make your own notes. Okay,
Yes, sir.
I think half an hour if you devote, you can make your own notes. Okay.
Yes, sir. But
So
I don't think I can take screenshots.
okay, I will save it. I'll send it to you after the class. Okay, I you can
O-
take screenshots. Why not? You can take. Okay, let me write one screen, one page, and then you see if you can. Okay.
Okay.
Okay, so we will start with coordinate systems. Okay, so today's class will be little bit tough. Okay, because I'll be dealing with spherical coordinate system and coordinate cylindrical coordinate systems. Okay, so you will feel little bit difficulty. You let me know if you have any problem. Okay, because this coordinate system I want to introduce now because it will come everywhere. Okay, maybe in the beginning, like when we do, we will just see rectangular coordinate system, but as we move to rotational motions and even in electrostatics, Gauss theorem, you will frequently encounter cylindrical coordinate systems and spherical coordinate systems. Okay, so it is better to get introduced to these concepts at the very beginning so that you know this concept beforehand. Okay, so you just let me know if you are feeling any difficulty. I'll show you some diagrams if you are not able to visualize. Okay, are you getting me?
Okay, sir.
Yeah.
Yes, sir.
So let's start with rectangular coordinate systems. Okay, so rectangular. I think this is easy. This you would be knowing before. So, so what do you mean by rectangular coordinate system? So the coordinate axis should be rectangular to each other, means it should be perpendicular. Okay, so that is called rectangular coordinate system. So rectangular coordinate system are two types. One is right-handed system and left-handed system. We will be always using right-handed system. Right-handed system means when you take x-axis and y-axis and you take cross product of a unit vector along x-axis and a unit vector along y-axis, you should get z-axis. That is called right-handed system. Are you getting me? So
Yes, sir.
right-handed system means right-handed system means I cross j should give you k. Okay, that means if you use your right hand and if you place your palm along x-axis and you move towards y-axis, your thumb should point towards z-axis. That is what is called as right-handed system. Any doubt?
No, sir.
Okay. Now in right-handed system, so let's say any point in space is P. Okay, there is any point in space. This is three-dimensional. So imagine you are in a room and then any point is in space and one corner of the room you have fixed your axis like this. So maybe the plane of the room, that ground of the room, right, that is xy plane, and that is one corner is the origin of the room, and the z-axis is the axis attached to the wall. Okay, in the one corner, are you able to visualize?
Yes, sir.
Okay. So if there is a point P and we call this point as X, Y, and Z, okay, the coordinates are X, Y, and Z, then if you drop a perpendicular from P on the XY plane, okay, so if you drop a perpendicular from P on XY plane, then this point and you will get on the ground, right, on the xy plane. So from that point you drop a perpendicular on y-axis and drop a perpendicular on x-axis. So let's say if I drop a perpendicular on y-axis like this, okay, and x-axis like this, these are the perpendiculars on x-axis and y-axis. Are you getting me?
Yes,
So
sir.
this is the perpendicular on x-axis and this is the perpendicular on y-axis. Okay, so this length is your x x coordinate and this length is your y coordinate. I think this you would be knowing from before also if you've done mathematics. Understood? So these are
Yes,
your
sir.
x coordinates. This is your x coordinate of the particle. This is the y coordinate of the particle. And the length of the perpendicular that you have drawn, right? That is the z coordinate. Or otherwise, to look into it, is like from that point you drop a perpendicular on z axis, like this. Understood? So the length on the z axis will give you the z coordinate. Okay. So this is the z coordinate of the particle. Okay. So you are able to visualize this thing. This is three-dimensional figure. Okay.
Yes, sir.
So this is the x coordinate, y coordinate, and z coordinate. That is what we mean by x, y, z coordinate of any point P in space. Okay.
Yes,
Now,
sir.
what is position vector? Position vector is a line joining the point P from the origin of your coordinate system. Okay. So this is called as R, which is the position vector of the point P. Okay. So now, if you know triangle law, so basically triangle law says that if there is any vector A, and there's any vector B, where the tail of the second vector should start from the head of the first vector. Okay. Then the vector which joins the tail of the first one to the head of the last one is the resultant vector. That is what is triangle law, right? You would
Yes,
know
sir.
the triangle law. So A and B, so this is resultant vector R. Okay. See, I am having some assumptions that you know few things. Okay. If you don't know, then let me know. Then I can go into detail of that. And if
Yes,
you
sir.
know,
Yes, sir.
then why to waste time? So we can quickly cover that. Okay. So I think triangle law and all you would have already covered in coaching. So, but
Yes,
remember,
sir.
triangle law, the very important thing is that when you add two vectors, the tail of the second vector should coincide with the head of the first vector. Okay.
Okay.
That is the most
Sir,
important thing in triangle law. Yeah.
sir, but I have a problem with an angle between this thing.
Yeah. Okay. I'll tell you. So whenever you apply triangle law, always take the angle between either tail to tail or head to head. Okay. Always the angle is between two heads or between two tail. Never take the angle between head and a tail. So if you when you apply the formula, you should not take this angle. This is the angle between a head and a tail. Understood? So you should always take the angle between two tails or between two heads. So basically what I mean here is like if you any vector is there, no, that vector you can extend. So you can basically translate this vector like this. So the same vector A can be also thought of like this. Okay, you can just extend the head, then it becomes tail. So the angle between the tail and the tail. So this is the angle that you have to take. Understood?
Okay.
Any doubt?
Sir, but can't we take the angle between R and A?
R and A. No, R is the resultant. That is the resultant of A and B. So this angle is the phi. This is the angle of the resultant vector. Okay. When
Okay.
you apply the formula that R is equal to under root of A square plus B square plus 2AB cos theta. Okay. This theta is the angle between A and B. So when you take angle between A and B, angle between A and B vector is the angle between the tails of A and B or angle between the heads of A and B. It should not be the angle between head of A and tail of B. It should not be this angle. That is what I mean. It should be always this angle. So how do you find the angle between two tails? So whenever you apply triangular, just extend that vector A. Okay, like this. And then you see, okay, tail of B and tail of A, what is the angle between them? That is the theta. Understood?
Yes, sir.
Okay. Yeah, so coming back to here, so what I'm telling, if I apply triangle law here, so vector R can be thought to be resultant of this vector, okay, plus this vector. So this vector. Are you getting me? So
Yes, sir.
basically, I can write that vector OP. Let's call this point as M. Then I can write that vector OP is nothing but OM vector plus MP vector from triangle law, right? Because see, this is the vector OM is like my A vector. So the head of first vector is coinciding with the tail of the second vector. Second vector is MP vector. Okay. Then the resultant vector is from the tail of the first one to the head of the last one. So that is my vector R. Is that clear?
Yes, sir.
Okay. And feel free to ask anything. Okay. You should not go with doubt because theory you should be very clear about. Then only you'll be able to apply this in problem. Okay. So from triangle law, I have written this. triangle law of vector addition. Okay, so OP vector I will write it as OM vector plus MP vector. Now OM vector also I can write OM vector as vector this thing, let's say call this as N, this point where the perpendicular from M falls on the x-axis, and this point let's call it as P. P is already there, let's call it as Q. Okay, so this vector I can write it as this vector, okay, plus this vector, this vector. Okay, so in I can write that vector OM is equal to vector ON plus vector NM. Is this clear from triangle law again?
Yes, sir.
Okay, so vector ON is what vector? This is the x coordinate. I told you length of the vector ON is x coordinate, correct?
Yes, sir. X plus Y.
Yeah, x, this on is this vector, on is my this vector, so this is the x
Yes, sir.
coordinate. So on into any vector, if I have to write, always remember any vector, if you have to write the magnitude of the vector into a unit vector in the direction of that vector. Okay, so unit vector, this vector is along x axis, so unit vector along x axis is how, what I
I
got,
cap.
so x I cap. Okay, similarly I'll write nm vector. So you can see that nm vector magnitude of nm is same as the magnitude of oq,
Yes,
correct?
sir.
These sides are same because it is a parallelogram, right? Both are 90 degree, it is a square basically, a rectangle. So nm is equal to oq. So I can write nm vector as y coordinate into a unit vector along nm, and a unit vector
J cap.
along nm is j cap, so I can write it as j cap. Understood? So this is my
Yes, sir.
OM vector. Okay. Now equation one, let's put this in equation one. And one more minute, this thing MP vector. Okay, MP vector is let us write MP vector. So what is the magnitude of MP vector? It is same as the z coordinate. This side is same as this side. Understood? So MP vector is the magnitude wise it is z, and the direction is along k cap, because this unit vector is your k cap.
Got
Got
it, sir.
Okay. So I will write OP vector equation. If this was my equation one, so I will write OP vector as, so OP vector I will write it as OM vector plus MP vector. And what is my OM vector? XI cap plus YJ cap. Okay. And my MP vector is what? Z cap. So that is what is the position vector. OP vector is called R vector, which is the position vector, which is nothing but XI cap plus YJ cap plus ZK cap in Cartesian coordinate system. Understood?
Yes, sir.
This you have to remember. This you have to understand the visualization of this. I think, did you do that question in SC Verma? That mosquito net wala question was there, right? Something. Did you do that question?
Yes,
Uh,
sir. I've done, I guess.
yeah, so did you get that question? Let's come to that question. I think it was this one. A mosquito net over 7 feet. Question number 9.
Page 29, sir.
Page 29. Yes.
Okay, yeah.
Did you get that?
I got A part I got.
Okay. So let me quickly show you this question. Okay. So we can apply whatever you have learned now. So there is a mosquito net. So basically, it is a, you can assume that, okay, this is your room. So, okay. So this is one corner of the room. Let's assume that this is one corner of the room. So your place your coordinate axis there. So if you place your coordinate axis, let's say this is your z axis. Okay. This is your y axis, and this is your x axis. Understood? So let's say this is your x-axis, y-axis, and z-axis. Can you visualize this? This is one corner of the room. Okay.
Yes, sir.
So mosquito net is 7 feet by 4 feet, and bed is 3 feet high. Okay. So basically, you can assume that this length is given as 7 feet, the room length. So basically, this
X is 7, Y is 4,
right.
and Z is 3.
Yeah. So you can assume it to be 7, 4, and this is 3. Okay. So, which is more, it flies and sits at the diagonally opposite upper corner. So, what is the diagonally opposite upper corner? This one is the diagonally opposite upper corner, right? So, what will be the position vector? What is the coordinate of this point? This point is just like diagonally opposite. So, its x coordinate is how much? 7 feet. Y coordinate is how much? 4 feet, and z coordinate is how much? 3 feet.
3 feet.
So this point's coordinate I can write it as 7 comma 4 comma 3. Is this clear?
Yes, sir.
Yeah. So find the magnitude of the displacement. So displacement vector is which one? So this one. So basically,
Or
uh,
straight connecting the origin and that.
yeah. So this will be any this thing. So I will come back to this in kinematics also. So whenever you have to write displacement vector, right? So delta r vector is nothing but position vector of the final point minus position vector of the initial point. So position vector of the final point is what? 7 I cap plus 4 j cap plus 3 k cap, because just now we have seen that if xy coordinates are given, then I can write position vector. So this is the position vector of point P, and position vector of initial point was where it was at origin. It was sitting at one corner, so it is 0 I cap plus 0 j cap plus 0 k cap. So displacement vector is always final position vector minus initial position vector. So this is your answer: 7 I cap plus 4 j cap plus 3 k. Understood? Now the
Yes, sir.
second part is taking the hole as the origin, the length of the bed as the x-axis, its width as y-axis, and vertically up as z-axis. Write the components of the displacement vector. So this is what is the component. That is what they are asking, like 7 I cap plus 4 j cap plus 3 j cap. These are the component. So basically, x component of displacement we'll call it as delta x is 7, delta y component of displacement is 4, and delta z, like the z component of displacement, is 3. Because delta r vector, you can write it as delta x I cap plus delta y j cap plus delta k cap. So you equate both sides, you will get delta x, delta y, delta j. Any doubt?
No, sir.
Okay. So let's come back to the coordinate systems. So this is what is the rectangular coordinate system. Okay. So you should know what are the unit vectors I cap, j cap, k cap. What is the position vector x I cap plus y j cap plus z k cap. What is the displacement vector? It is nothing but change in the position vector. So it is delta x I cap plus delta y k cap plus delta z k cap. Okay, here let me write this also. So delta r is equal to delta x I cap plus delta y k z cap cap plus delta z k cap. Okay. Now, let's say if I have to write differential length in rectangular coordinate system. Okay. So these things are very important throughout the physics we'll be applying. Okay. So differential lengths. Okay. So yeah, before that, I think you would be knowing, right, how to calculate the cross product. So you can always apply this cyclic order rule. So if there is a I cap is like this, j cap is like this, and k cap is like this in anti-clockwise order, then whenever you move in anti-clockwise order, okay. So if you write I cap cross j cap, you should get k
It'll
cap.
be K cap
Yeah. Similarly, j cap cross I cap should be j cap cross k cap.
minus K cap.
Yeah, like that, right? If you move in
Yes, sir.
clockwise direction, then minus of this. So that you should know.
Yes.
Now differential length. So what I'm let's say you have the coordinate axis like this. So x-axis, y-axis, and z-axis is given, and then you have to choose a differential length in any direction. Okay. So let's say there is any rod, vertical rod like this. So let's say a rod is here like this. Okay, a linear rod is there. It is along x-axis. Then I will choose a differential length like this. Okay, or for simplicity, let us assume that if the rod is along x-axis, okay, like this. So I will choose a differential length like dx, right? So what in whenever we'll apply calculus, will be applying throughout. Okay, so what will be the method is that I will go at a distance x, okay, and then I will take a cut of dx length like this. Whenever you have to choose a differential length, so this length will be dx, and it will be at a coordinate of x from origin. Okay, so the differential length that you have, the coordinate of differential length will be x comma 0 comma 0, and the length of that differential length will be dx. Is that clear?
Yes, sir.
If let's say lambda is the mass per unit length, then the mass of this small length will be lambda dx. Okay. Let's say if lambda is the charge per unit length, then the charge on this small length will be lambda dx. Okay, in various so we'll be applying in gravitation, we'll be applying these things in electrostatics. So that you should know always what you will do, you will go at a coordinate x, and from that coordinate you will go to x plus dx. This coordinate is x plus dx, right? So the length intercepted between x plus dx and x is your dx length. Understood?
Yes, sir.
So similarly, let's say some rod is here along y-axis. So you will go at a coordinate y, and that y plus dy, and you take a very small length which is dy. So this length will be dy. Okay. And similarly, if mass per unit length is lambda, then the mass of this small dy length will be lambda dy and lambda dx if the charge is there. Okay. Similarly for z. So this is how you choose a differential length. Let's say if you have to write the differential length vector, then how will you write? So if the length you have chosen is along x-axis, then you'll simply write it as dx into y cap, right? If the
Yes,
length,
sir.
the differential length that you have chosen is along y-axis, then you'll simply write as dy into j cap. And similarly, if you have chosen the length along z-axis, you will write dz into k cap. What if you have chosen the length arbitrary, like if you have chosen the length like this, okay? Any differential length like this.
You take the position vector.
Not position vector. So what you have to do is this dl vector, any dl vector like this, can be assumed to be from triangle law. I can write that this is this vector plus this vector, right? So this vector will be the dx I cap vector, and this vector will be dy j cap vector. So this is your dl vector. So in general, you can write dl vector as dx I cap vector plus dy j cap vector plus dz k cap vector. Are you getting me?
Yes, sir.
So this visualization should be clear. Like if you have arbitrary, the rod is like this, rod is placed like this, then you will choose a small, you will go to any arbitrary coordinate x comma y. From there, you will go to x plus dx and y plus dy, and then you will choose this length. So this length vector is dx I cap plus dy j cap plus dz k cap. Any doubt in this?
No, sir.
Okay. So this is how you choose a differential length in rectangular coordinate system. Okay. Now let us see that if I have to choose a differential surface. So you now try, you can save this page.
Okay, let me try, sir. 1 minute.
Could you show
Just
it?
1 minute, sir.
Okay. Just take a print screen or a screenshot. Otherwise, I have saved. I can send it to you after the class.
Okay, I saved it.
Okay. So let us quickly write the area vector. Okay. So slowly now I will accelerate. Okay. So if you have problem with the speed and all, then you tell me. Okay.
Yes, sir. Sir, just 1 minute. I'm saving it.
Mhm.
Okay, I saved it.
So okay. So let us write area vector. Okay. Area vector in a rectangular coordinate system. Okay. So what I mean is that area is always a vector. Okay. So what is that? Is the area vector means it is the if I call this a vector S, then it is a magnitude of the area into a unit vector along the direction of the area vector. And direction of area vector is always perpendicular to the area. Okay. Let's say if you have an area like this, and it is a, let's say it is a rectangle, and it is a and b are the lengths, then I'll write area vector as a b into a unit vector perpendicular to this area, okay, which is n cap. So this is
Sir,
what,
why do we do that?
because we will be applying it in Gauss law, and also area vector is defined like that. It is always a vector perpendicular to the area, okay, and magnitude wise it is same as the area of the whatever element you have chosen. Okay,
Okay.
this is how area vector is defined. It is a mathematical
It'll be
construct.
perpendicular to the area.
Yeah, always perpendicular to the area. Okay, and whenever you have two perpendicular, let's say you have a cubical shape like this. Okay, so any surface if you take, you have two options. The perpendicular is either going outward or going inward, right? There are two perpendiculars possible. So which one will you take? So always you take the going outward, out of the surface. That perpendicular you have to take as the area vector direction. Is that clear?
Sir, but in cube there are like multiple faces, right?
Yes, any particular shape face I am talking about. Any particular face you take, you have two options. You can either take this area or you can take this area vector. Okay. So which one will you take? Whichever is coming out of the shape for every face.
Okay.
Every face. Let's say this face is there. Then for this face also there is this vector or this vector. Which one you will take? Which is coming out.
Okay, I got it.
Understood. So yeah, so basically in rectangular coordinate system, how will you choose your area vector is, so there are three planes, right, in rectangular coordinate system. So basically you have xy plane, yz plane, and zx plane, right? So if this is your x-axis, y-axis, and z-axis, then how many planes you have? You have this plane. This plane is xy plane. So any area if you take in this plane like this, okay. So
It'll be towards z-axis.
yeah. So any differential area, okay? Differential area, what I mean is that this length will be very small length, okay? Always. So this thing is dx. Let's say this is dx, and this is dy. And it, what you do, no, basically in calculus method, what we do, always go at a coordinate xy, okay? And then we move to x plus dx, so that this length is x dx, and we move to y plus dy, so that this length is dy. Okay, and this is how we create our area element. Understood? So we'll be always
Okay.
doing the same technique whenever we have to apply calculus thing. Okay, we go
Sir,
to,
could you tell that once again? Just
yeah, so you go to xy coordinate, okay, any point
okay.
plane of xy, and you move to x plus dx. So what will be this coordinate? This point's coordinate will be x plus dx comma y. Correct? This point's coordinate.
Yes, sir.
Similarly, this point's coordinate will be what? It will be x comma y plus dy. And this point's coordinate will be x plus dx and y plus dy. Right? This point's coordinate.
Yes, sir.
So what I'll do, I'll go to any generic point xy, and then I will move dx distance, and I move dy distance in both direction, and then I'll create my area. Understood?
Okay, yeah.
So the
Yes, sir.
area of this vector, if I write ds vector, let's call it as ds vector, then magnitude of the vector is dx into dy, correct? Because it is a rectangle. And the
Yes,
direction
sir.
of the vector will be perpendicular to that, and perpendicular to this area will be along z-axis, because any vector perpendicular to the xy plane will be along z-axis, right? So the unit vector along perpendicular will be k cap. So I can write this area vector as dx into dy into k cap.
Okay, this we use in electrostatics, right?
Yeah, electrostatics, mechanics, everywhere we'll be using. That's why this is my first class. Okay. So my
Yes.
first class, I always teach coordinate system. So rectangular coordinate system is easy. Then we'll slowly move to polar coordinate system, and then cylindrical and spherical. Okay. If you understood this three coordinate system, then you won't have any problem in electrostat, gravitation, rotational, and all that. Okay. So it is very critical to understand that. So let me know when slowly you will feel that it is becoming difficult. Okay. So you let me know when you think it is too tough, then I'll show you some diagrams, maybe then it will become easy. Okay. So when I teach spherical coordinate system, no, you take a ball with you, okay, and then sit, maybe tomorrow or whenever we do. So take a ball, and for cylindrical coordinate system, just take a bottle kind of shape, cylindrical shape with you. Then I
Okay.
explain. So um, yeah, now let us take that the area vector, if I choose in different plane, not in xy plane. Okay, so how will I do? So let's say that if I choose in the xz plane, so my area vector will be like this. So my area vector will look like this, and Getting it? You're able to visualize this area. It is one of
Yes,
your
sir.
wall of the room. Okay. So this area, similarly, you'll do what you will do. You will go to any point whose coordinate is x comma z, and then you'll move to dx distance along x-axis. So this coordinate becomes x plus dx and z. So this coordinate becomes x plus dx comma z. Similarly, you move dz distance along z-axis. So this coordinate becomes uh,
X comma Z plus DZ.
Y coordinate I am not writing here. Y coordinate is 0. So actual coordinate should be basically, if you are writing like this, you should write like x plus dx comma 0 comma z, right? X plus dx comma 0 comma z. Similarly,
Yes, sir.
here you should write x comma 0 comma z plus dz. Understood? The y coordinate is 0 in this plane. In xz plane, y coordinate is for any point you take in xz plane, y coordinate is 0. But you have to write that coordinate, right? So basically in coordinates, we should write x plus dx comma 0 comma z. And similarly, you should write x comma z, x comma 0 comma z plus z. Okay. So this is your rectangle. So rectangle's area, this ds area, what I will write? The magnitude of the area, and magnitude of the area is how much? This length is d.
DZ into
Yes.
DX.
Yeah. So this area I will write at dz into dx into a unit vector perpendicular to the area. So can you tell me which unit vector it will be?
J cap.
No, it will, yeah, it will be j.
No, minus.
Yeah, minus
Sir,
j or plus j cap, you have both the option. Now it depends like what kind of area. If it is a closed shape, I'll take going outward. I don't have a shape here, closed shape, right? If it is a closed shape, then I will take going outward. Okay, but I'm just taking it this as an example. So if let's
sir,
say,
it is a closed shape, right?
no, no, it is just a area. This shape is not a closed. Closed shape would have been if it is like this.
Okay. Okay,
It's
yeah.
not a closed shape. In that case, we'll take,
Okay, there's just one surface.
yeah, just one surface. So here you can take anything. So for example, we'll just take positive. So we'll write G. Understood?
Okay, yeah.
So similarly, in the same figure, I can we can draw the this area, basically the area in YZ plane. So YZ plane area will be, it will be simple. You can write like this. Okay. So same thing. We'll go to a coordinate whose coordinate is in YZ plane. X coordinate is always 0, and this is YZ. So I will move 0 comma y plus dy comma z, and similarly I'll move y 0 and z plus dz. Are you getting me? And this point's
Yes, sir.
will be 0 comma y plus dy comma z plus d.
Comma Z plus DZ.
So this length is how much? This length is your dy length, and this length is your dz length. Correct. So this area, ds area, I can write it as dy
DZ into DY.
into a vector along perpendicular. And what is that vector? That
I
vector.
cap.
You're getting me? So this is
Yes,
your
sir.
I cap. So this vector. So this is how we write area vector in rectangular coordinate system. You can take that area in xy plane, yz plane, zx plane. It depends on case to case basis. Okay, let's say a sheet of charge is placed. Somebody is writing that a sheet of charge is placed along xy plane like this. Okay, this is the xy plane. It has a sheet of charge, means charge is there throughout. Okay,
Yes,
then we'll take this kind of area. Understood?
yes,
If
sir.
the sheet is placed along this, then we'll take this in a YZ plane. If it is like this, then we'll take this plane. Okay, so
Sir,
continue this
what
problem.
if,
Yeah,
sir, what if like the sheet is like completely protonic, then the electric field and the area vector will be in the same direction, right?
we'll come to that. When we'll do electrostatic, we'll come to that. Okay, we'll do the electric field, how to write electric field, I'll tell you on that. Okay, don't worry about that. This, how to choose the area vector, this you understood now?
Yes, sir. Yes, sir.
So I'll come to electric field out. Okay, just give me 2 3 class, then I'll tell you the basic electric field and all, then you will understand. Okay.
Yes,
So
sir.
let us write now. We are done with area vector. Let us write differential volume. Okay, so differential volume in rectangular coordinate system. Okay, so this you have to understand. Okay, it's little bit tough. So uh, first draw your coordinate axis. And always whenever you are doing physics problem, no, your coordinate first thing is that you should define your coordinate axis. Okay, and once you are done that, then it will be very easy. Okay, so as soon as you start your physics problem, you draw your coordinate axis. Okay, so let's say this is my x-axis, y-axis, and z-axis. Now there is only one volume, and that volume is what is, if you go to x, y, z plane, any point in the space which is x, y, and z, and you imagine a very small cube, okay, which length is dy, dz, and dx, like this. So basically, you are constructing a cube of length dx, dy, and dz. Are you getting me?
Yes, sir.
Can you visualize this? I am
Yes, sir.
constructing a cube of length. This length is dx length. Okay, this length will be dy length, and this length will be dz length. Okay, so I am going at a point x. I am moving along x-axis with x plus dx, y-axis with dy, small difference in the displacement dy, and z-axis dz. Then I will have a very small cube, right, in this space, whose length, breadth, and width will be dx, dy, and dz respectively.
Yes,
Right?
sir.
Yeah. So what is the volume? dv volume of this is a cube, very small cube. So cube's volume is dx, comma dx into dy into dz. Understood?
Yes, sir.
So this is the differential volume in rectangular coordinate system. Okay.
Yes, sir.
And volume is a scalar. We will not assign any vector with this. Area is a vector
Yeah,
quantity.
because you can't define a direction for any volume.
Yeah. So for volume is always considered to be scalar. Area is considered to be vector, because area we can define a vector which is perpendicular to the surface. Okay.
Yes, sir.
So this is your rectangular coordinate system. So I covered this thing: length dx I cap, dy j cap, dz k cap. Area is dx dy k cap. Similarly, other areas, and volume. Okay, and the position vector, how to write: x I cap plus y j cap plus z k cap, and change in position vector is delta x I cap plus delta y j cap plus delta z k cap. Is that clear? So
Yes,
this is
sir.
what to remember about rectangular coordinate system. And I know that I think you would be knowing, if there is two vector in rectangular coordinate system, then cross product of two vector a cross b is defined as I j k ax, ay, az, bx, by, and bg. This you would be knowing, right? So this is only valid for rectangular coordinate system. Okay,
Okay, yeah.
it is not valid for other coordinate systems.
Yes, sir.
Okay, now let us move to the next concept, which is called polar coordinate system. Okay, so polar coordinate system we will do in first 2D. So polar coordinate system in 2D. Okay, so okay, so let us first try to understand what is polar coordinate system with respect to your rectangular coordinate system. Okay, so let's say in 2D figure, I can draw xy axis just like this. No need to draw like this. So imagine it is the xy plane in this figure. Okay, thus I can draw it like this: xy. Understood?
Yes, sir.
Yeah. So let's say any point is there in space whose coordinate is x comma y. Okay, it is in plane, it is two dimensional. Okay, we can also write this coordinate as r comma theta, which is in which is called polar coordinate system. So in this system, what is r is the this position vector's magnitude is r, and the angle that it makes with positive x-axis, always remember, with positive x-axis is theta. Okay, this is the theta. Theta is the angle that vector r makes with positive x-axis. Understood? Always with
Yes, sir.
positive you have to take. Okay. So suppose if the point is like this, then you have to take this angle. Understood?
Yes, sir.
Okay. So what is the relation between r and xy? This you would have done in mathematics also. So
Yes,
what?
sir. Root of x square plus y square. That will be the magnitude of r.
Yeah, magnitude of r, or in terms of triangle law, you can understand it like that: xi cap plus yj cap, right? So you can write this vector r as xi cap plus yj cap. Okay, and magnitude of r is under root of x square plus y square, and this tan theta is nothing but y by x. Understood?
Yes, sir.
So
But that's y by x only in first quadrant, no?
yeah, tan theta will this see whenever it is in this coordinate, the magnitude you all what you do always find out the magnitude of this theta. So you take modulus of y by x, okay, and then you
Okay.
decide in which quadrant it is, then you add or subtract pi whatever. Let's say, for example, if there is any vector like this, okay, then what I will do, I will take magnitude of y. Let's say this coordinate is 2 comma minus 2 comma 3, okay, then the magnitude of y by x will give me tan inverse 3 by 2, 2 by 3. Right, this is 3 and this is 2. So what I will do is that tan theta I will write mod of y by x, which is nothing but minus 2 by 3. So I will write it as 2 by 3. Okay. So
Sir,
this,
it will be pi minus tan inverse of 2 by 3.
no, no, I'll come to that. I'm coming. So what I'm telling, how will you write? You first write the magnitude. So that will give you this angle. Magnitude will always give you the acute angle.
Yes,
Okay.
sir.
So this will give you this angle. But I know it is in second quadrant. So the angle that the vector will make it pi minus tan theta. So I'll write the answer as pi minus tan theta. Understood? Let's say if
Yes,
it
sir.
is in third quadrant. So this is same concept is applicable in complex number also. Let's say number is here in third quadrant. Okay. So what I'll write, so this coordinate will be, let's say, minus 2 comma minus 3. So I'll write this magnitude first. Okay. So this will give me this angle, acute angle. So I'll write tan of 3, 3 by 2 means I'll write tan theta as 3 by 2. This will give me this theta. But my theta is this theta. So I will write it as
Oh,
pi plus tan theta.
so we can even write minus pi plus theta, right?
Yeah, so it is if in terms of complex number, principal argument is always defined between 0 to pi or 0 to minus pi. So in complex number, you write this angle. Okay. So this angle is
Okay.
how much? Minus pi plus theta. If theta is your distance. So always first
Okay.
find the acute angle, which you can find by taking the modulus, and then you see which quadrant it lies in, and then you do the accordingly. You can change like pi minus or pi plus or 2 pi minus theta or 2 pi plus theta, in which quadrant it lies. Based on that you can do. But in complex number there is something called principal argument, which always lies between 0 to pi or 0 to minus pi. So if it is in third quadrant, you have to take the smaller angle. So principal argument is, see, once you find out this, no, so out of this and this, which is smaller, that you have to take. So smaller is minus pi plus theta, right? So we always take the smaller one, that is called principal argument. So principal argument we can write minus pi plus theta. But here in coordinate geometry, you have to always write this angle, the angle with positive x-axis, and in anti-clockwise direction.
Okay.
Getting me? Complex
So
number
I
is,
should write pi plus theta.
yeah, you have to write here pi plus theta. You should not write minus pi plus theta. Minus pi plus theta is the principal argument of that complex number, represented by minus 2 comma 3 minus 3 item. Okay. But
Yes, sir.
in coordinate geometry, you have to always write the angle with positive x-axis in anti-clockwise direction. Understood? In
Yes, sir.
anti-clockwise direction. Any doubt?
No, sir.
So how will you find that angle? First, find the magnitude of this angle, and then you, in which quadrant it lies. Based on that, you add pi, subtract pi, or whatever. Is this point?
Then if it is in fourth quadrant, then I have to do all the way to like 3 pi by 2 plus theta.
No, I'll
Or
tell you. Let's say this is a fourth quadrant point. Fourth quadrant point will be like, let's say, 2 comma minus 3. Okay. So first you find this angle. This angle will be what? Tan theta is again, tan theta is equal to mod of minus 3 by 2, which is theta by 2, 3 by 2. So this thing modulus, when you do, you will always get the acute angle, this acute angle, theta. Okay. But your actual theta is what theta? Actual theta is the angle with a positive x-axis in anti-clockwise directions, which is this angle, right?
okay.
So this angle is 2 pi
Oh,
minus theta.
yeah, 360 minus theta. Yeah.
So you have to do 2 pi minus theta. But in complex number, your principal argument will be minus of theta, because this is the angle. And any angle you take in clockwise direction is negative. Okay. Let's not get confused with complex number now. Okay.
Yes,
So
sir.
in coordinate geometry, you have to always remember, you have to take the angle with positive x-axis in anti-clockwise direction. Okay. Is
Yes,
it?
sir.
So how will you find that angle? You always take the modulus, find the acute angle and which coordinate it lies. Based on that, you can take the anti-clockwise direction angle. So in
Yes,
fourth
sir.
quadrant, it will be 2 pi minus 3. In third quadrant, it will be pi plus theta. In second quadrant, it will be pi minus theta. In first quadrant, it will be theta, where theta is the acute angle, which is obtained by taking the modulus of y by x.
Yes, sir.
Any doubt?
No, sir.
Okay.
Sir,
So,
1 minute. I'll take screenshot.
okay. Yeah. Done?
Yes, sir.
Yeah. So, yeah, so this is the polar coordinate r and theta you find. Okay, r is your root of x square plus y square, and tan theta is y by x. And I told you how to take the which coordinate lies. Okay, now let us come to the unit vector. Okay, so in polar coordinate system also we define unit vectors. Okay, so so let's say your polar coordinate system is like this. This is your x-axis, this is your y-axis, and let's say your position vector is anywhere like this. Okay, so this is your point P, and it has the position vector r. Okay, so I know that this length is the r and comma theta. So first of all, let us find out what is the relation between rectangular coordinate and polar coordinate. Let's say this is x comma y. So what you do is you do draw a perpendicular from here, and if this angle is theta, then this will be your r cos theta.
R cos theta I cap plus R sin theta J cap.
Yeah. So x coordinate is nothing but r cos theta, and y coordinate is nothing but r sin theta. Okay. And one more thing I'll tell you, which if theta is whatever, okay, in whichever quadrant, you just have to do r cos theta. You don't have to do plus minus pi minus theta, pi plus theta, nothing. First find out theta and just do r cos theta. That will give you the x coordinate. It may come positive, negative, depending on which quadrant it lies. Understood?
Okay.
So let's say if your theta is here, if the point is here, this theta will be obviously it will be this theta. Okay. So r cos theta will come out to be negative, and which should be because it is in second quadrant. Got it? So you have to just do r cos theta and r sin theta. That will give you x coordinate and y coordinate. Clear?
Yes, sir.
Okay. So this is the relation between polar coordinate and Cartesian coordinate. So any coordinate, if is given in polar coordinate, you can go back to Cartesian coordinate, and if it is given in rectangular coordinate or Cartesian coordinate, you can go to the polar coordinate. Okay. Now, one most important thing that I am going to tell you with respect to the physics is like there is two vector we will define. Okay. So if there is a vector r like this, position vector like this r, then I define a vector called ur cap. Okay, ur cap is a unit vector along the direction of r. Okay, radially outward. So my unit vector ur cap is a unit vector along this direction. Unit vector means magnitude wise it will be 1 and direction wise it will be radially outward. So this vector I call it as ur cap. Is this clear?
Yes, sir.
Now, a vector which is perpendicular to the position vector and magnitude wise 1 is called as u theta cap vector. This vector we will call it as u theta cap. Is this clear?
Yes, sir.
U theta cap vector will be always in the direction of increasing value of theta in anti-clockwise direction. Okay, you had two options. You could have to told this thing also u theta cap, but no. We will always tell it is in increasing value of theta in anti-clockwise direction. So this was your theta. So you go to theta plus d theta, you will lie in this region, right? So this region, whatever u theta here is coming, that you have to take. Is this clear?
Yes,
So
sir.
you will not take this one. So this will not be the direction of u theta cap. U theta cap direction is always in the direction of increasing value of theta in anti-clockwise direction. Is this clear?
Yes, sir.
So this is my vector u theta cap, and this is vector u theta u r cap and u theta cap. Okay. So let us write down. There is a if there is a small. Okay, and then one thing you can write. This I've already told you, right? Let's say r vector, you can write xi cap plus yj cap. Right. Now r vector you can also write it as magnitude of r into u r cap. Correct? Because what is r vector? R vector is the magnitude of the vector into a unit vector in the direction of r, and the unit vector in the direction of r is which vector? U r cap. So I can write position vector r as r into u r cap. Is this clear?
Okay, sir.
Yeah.
So when I write like r cos theta and r sin theta,
Mhm.
I don't have to mention I cap and j cap. I can directly mention UR cap.
Yes. That is why it is a different coordinate system. Okay, that is why we call it as polar coordinate system. Polar coordinate system, when you work, you don't have to take I cap, J cap. You have to always deal with R and theta and U R cap, U theta. Okay, yeah, but it is interconvertible. You can convert back to rectangular coordinate system, and if you have rectangular coordinate system, you can come to this coordinate system. Understood? But we'll see in circular motion all that. We'll be always working with polar coordinate systems. This like this. Okay.
Okay, sir.
Okay. So this is vector R. Now, one more important thing that I'm going to tell you is that let us find out um, du r cap and du theta cap. What is the change in the unit? What is du r cap? Du r cap. Let us first ask. Let me ask you first. What is di cap? Di cap. What does it represent? It represents the change in the I cap vector. Okay. So change in I
Okay.
cap vector is always zero because I cap vector is a fixed vector. Okay, it is always along x-axis.
Yes,
Understood?
sir.
Similarly, dj cap is 0, dk cap is 0, but dur cap is non-zero. Why? Because as the point moves, let's say if the point is in space like in plane like
Yeah,
this,
even its resultant will change, so its UR cap also will
yes,
continuously change.
basically the position vector is here. After some time, particle will move somewhere here, right? Maybe particle is moving in the trajectory like this. Okay, so r vector was here, so ur cap was along the r vector here, but after some time when the point moved here, then ur cap came in this direction, right? So ur cap vector is not a fixed vector here, but in
Yes, sir.
x-axis, and when you had I cap vector, I cap vector was always along this direction, where the particle is here or here, it doesn't matter. I cap vector was always along x-axis, but ur cap vector, as the position vector moves, ur cap vector will move. Okay, because UR
Yes,
cap
sir.
vector is always assigned with the position vector. It is radially outward in the direction of the position vector. So if the position vector shifts, UR cap vector shifts. So DUR cap vector will not be zero, it will be non-zero. Similarly, DU theta cap vector will be non-zero. Is this clear?
Yes, sir.
So let us try to write what will be DUR cap vector. Okay. So if whenever let's say let me show you this vector. So this is basically, let's assume that this is the UR cap vector at any moment. Okay. And after some time in UR cap vector, let's shift it to here. Like let's say like this, became like this. Okay. So this was the UR cap vector now at time t, and this became your UR cap vector at time t plus dt. Okay, that means here it was UR cap vector was like this. After some time it became like this. So this is what I have. I can, the vector I can translate, right? So this vector I took it and I shifted it like this. This is what I have drawn here. Understood?
Yes, sir.
Okay, so from triangle law I can tell that this DUR cap vector is this vector. So basically this vector is dur cap vector. Why? Because your ur cap vector is what? Ur is final vector, so that is initial vector ur cap plus the change in that vector. Any quantity, final quantity, initial quantity plus change in that quantity, right? So
Okay.
you can
Huh.
write ur cap vector at time t plus dt is nothing but ur cap vector plus dur cap vector,
Yes,
right?
sir.
So this is your dur cap vector. Dur cap vector is like this. Okay, so but this thing is very small, these vectors are very small. Okay, it is very like this. It is almost close to each other. Du r cap is small change. So it you can see that du r cap vector will come along the direction of u theta cap, because if it is very small quantity, no, it will become perpendicular. So it will be like this, almost perpendicular to u r cap, and perpendicular to u r cap is direction is u theta cap.
Oh, yes, sir.
It is clear.
Okay.
It is very small. This angle is very small. This is a d theta angle.
Yes,
Okay,
sir.
means the particle was here and then it rotated by d theta, and it came here. It is like this. So it was ur cap was here, and then ur cap plus dur cap is here. So this small angle. So the change will be almost tangential, which will be u theta cap.
So
Are you
can
getting
we
me?
say that DUR cap is D theta cap?
No, there is nothing called d theta cap. It is u theta cap, du theta cap,
Sorry,
u theta
U
cap.
theta cap.
Yeah.
Sorry. Huh.
The direction will be u theta cap. Okay, u theta is the direction of dur cap. But what will be its magnitude? The magnitude will be, this is kind of a sector, right? So each vector is unit vector, so this is magnitude wise it is 1, this is 1, and the angle between them is d theta. So what will be this r d theta? So r is 1 and theta is d
D
theta.
theta.
So d theta, so magnitude wise it is d theta. So I can tell that du r cap vector is nothing but d theta into u theta cap. Is this clear? This is
Yes, sir.
very important. Okay, if it is not clear, you ask me, I can explain it again. Any doubt?
No, sir.
Okay. So similarly, we can write du theta cap. So basically, what it is happening is, let's say the particle was here. So uh, the particle was here, and then it slightly moved to a new position like this. So it slightly moved to a new position here. Okay. So this is your d theta. Understood?
Yes, sir.
Okay. So the u theta vector, if you draw, then u theta vector will be perpendicular to that. So at this instant, u theta was like this. Are you getting me?
Yes, sir.
Let me delete. So u theta was like this at this instant. After some instant, the u theta vector will be perpendicular to this guy. It will be like this. Are you getting
Huh.
me?
Yes, sir.
Okay, so it will be like this. Magnitude wise, both should be same. Okay, because it is almost both have magnitude 1 because it is unit vector. Okay, so it will come like this, like this. Okay, understood. So this is your u theta cap vector at time t, and this becomes your u theta cap vector plus du theta cap vector, right? The change in the du theta, change in the u theta. So from triangle law, I can write that this is my du theta cap vector. This is my du theta cap vector,
Yes, sir.
right? So this is very small magnitude. So you will see that du theta cap direction is along minus ur cap, because it will come almost opposite to this vector. This is ur cap vector minus ur cap vector, right? Because ur cap vector was like this. Are you getting me?
Okay.
So this will
Uh,
minus ur cap. So du theta vector direction will come minus ur cap direction. Is this clear?
okay. Yeah. Huh. Yes,
Okay,
sir.
because it is very small. Okay, and the magnitude of will be, if this angle rotates by d theta, it is the perpendicular to both of them, that will also be d theta. Yesterday I told you, if the angle between two line is d theta, then an angle between perpendiculars to each of the line is also d theta. So this angle is also d theta. Is this clear?
Yes, sir.
And these magnitudes are 1. Both the vectors magnitude is 1. So this length will be how much? R d theta, which is 1 into d theta. So magnitude wise it will be d theta. Is this clear?
Yes, sir.
So du theta cap vector, I can write it as du theta cap vector is nothing but minus d theta into u r cap. So these two relations are very important. That du r cap vector is nothing but d theta into u theta cap, and du theta cap is nothing but minus d theta into u r cap. You can just remember that du theta cap direction is along minus u r cap. So and magnitude wise both is d theta. So just attach
Sir,
a
could you like quickly tell about that second one? Du theta cap because D theta into minus UR cap.
Yeah, so what I'm telling is this direction, if you see, no, so let's say this was your u theta. After some time, it becomes du theta plus du theta. Okay. So
Yes,
from
sir.
triangle law, this is your direction of the u theta cap vector, du theta cap vector. So this was your u theta cap, and this vector is your u theta cap plus du theta cap. So this vector is your triangle law tells that du theta cap, correct?
Yes, sir. Huh.
So this vector you will see that it is the opposite. It is along this direction. It is almost these two vectors are parallel. Okay, and this vector is what? This vector is minus u r cap vector because u r cap vector was like this.
Okay, yeah.
This is
I got
minus
it.
u r cap. So the direction is minus u r cap, right? But I
Yes,
have
sir.
to write the magnitude, and magnitude wise, what I am telling, this angle is d theta,
Yes,
right?
sir.
And the length is 1 because it is unit vector. So 1 into
Okay, so it will be d theta.
d theta. So it is d theta into minus u r cap. Understood?
Yes, sir.
So this is the change in the u r cap and change in d u r cap. You can write like this.
Sir,
Okay.
can we sign of uh, any direction like UR cap? We can't shift it to the magnitude, right?
We cannot.
Like you have written d theta into minus UR cap.
Yeah.
So we can't bring that minus front, right? That
Then
is like specifying its direction.
no, no, no. This 5 I cap, 5 into minus I cap, you can write it as minus 5 I cap. It means that magnitude wise it is 5, but minus means it is minus I cap. People write
Oh,
it
so
both
it
ways.
will be ulta direction.
Yeah, opposite direction. Yeah. It
Okay,
is
yeah.
basically what you are telling is correct. You should always write like this vector magnitude into a unit vector in that direction. But people write it like this also. It is that is inherent, like okay, minus is coming before means it is opposite to the vector whatever you have shown.
Because in the class during electrostatics, someone said we can write minus outside and he scolded them. So
Yeah, yeah. So
I
minus
thought,
you can write, but you should people write it. Let's say if somebody is writing no 3 I cap minus 2 j cap plus k cap, how they are writing. You can write, but you should understand that this is magnitude wise it is 2, but direction wise it is minus j cap.
okay,
Understood? So
yes, sir.
magnitude of the vector is always 2. It is don't tell magnitude is minus 5 if you are writing like this.
Yes, sir.
Magnitude of the
Magnitude can never be minus.
yeah, magnitude can never be minus. So it is 5, magnitude is 5, but direction is minus I. So you can write both ways. Okay. So but you have to understand what you are writing. So you can write minus d theta into u r cap. If you are not comfortable, you can write d theta into minus u r cap. Both are same thing. Okay.
Yes,
Only
sir.
thing is that
Yes,
if
sir.
somebody is asking what is the magnitude, so magnitude is mod of d theta. Okay, and one more thing, magnitude of this vector is not d theta. You have to always tell mod of d theta because d theta can be positive or can be negative. If the particle is moving in clockwise direction like this, then d theta itself will be negative quantity. Are you getting me? Then the
Yes, sir.
magnitude of this vector is mod of d theta. You have to always take the modulus. D theta doesn't say that d theta is always a positive quantity. Are you getting me? Dr vector is never. It is not always positive. It can be positive. It can be negative. Dx is
Yes, sir.
dx quantity. If you are writing, it can be a positive quantity. It can be a negative quantity. Understood?
Okay, yeah.
Mod
So
of
theta is reducing, right? Like in that case.
theta is reducing. Then the magnitude of the vector will be mod of d theta. Similarly, if dx is if particle is moving in negative x direction, then dx is negative because x coordinate is decreasing. Then magnitude of the displacement is mod of dx, not dx.
Yes, sir.
So we'll apply these things. Anyway, don't worry about that. We'll apply. Okay. I can erase these things.
Yes, sir. Yes, sir.
So okay. So this you understood that du theta cap vector you have to write like this. U theta cap, u r cap. This you understood. These two.
Yes, sir.
Yeah. So we will use this in circular motion. Okay, when we'll do circular motions, let's say when we write, we can write in polar coordinate r vector as r into ur cap, right? Then what we'll do, we'll take the differentiation with respect to time both sides. So we'll get dr by dt as d by dt of r into ur cap. Okay.
Oh, okay. So they have done this only in NCRT.
Maybe, yeah. I have not seen that. You can check. Okay. So, and
Yes,
one
sir.
more thing I will request you when I am teaching, okay. So, first of all, one thing which is very difficult is whatever you know from before, okay. just forget that, don't try to apply that. Okay, so please stick to the conventions, whatever I will tell, because then if you have two different conventions, two different things, no, then it will get messed up. Okay, so you
Yes, sir.
don't read from any other source unless I tell you from where to read. Okay, don't refer to any other book uh, apart from whatever is recommended by me. Okay,
Yes,
and
sir.
don't try to use any concepts taught by anyone else. You just stick to me. Okay, have trust for few days, you will feel that you will be able to solve questions. Okay, but you have to just stick to me for few days. Okay,
Yes, sir.
till I do laws of motion and all, then you will automatically you will get that confidence. You will know, okay, this is correct way to do. Okay, if people, the most difficult thing that I face is when students come to me, they are enrolled in Fiji or LN or somewhere where they know something, and that may be wrong, they may be right, I cannot comment on that, but that is different. Okay, and knowing two different things always creates confusion. Okay, so just forget whatever you know, maybe if it is not aligning with what I am teaching. Okay, just
Yes,
align with
sir.
what conventions, whatever I am telling you, and stick to that and follow that, you will get questions. Okay, you'll get SC Verma, Eurodo, ITJ questions, everything you'll get. So you have to stick to me for a few days, then you will get that confidence. Okay,
Yes, sir.
physics is lot of conventions. Okay, physics is full of conventions. How do you take your positive axis? There is that, that is very important. Okay, so
Yes, sir.
it is very important to stick to one convention. Okay, anyway, so d by dt into r u r cap you can write. So both are variable quantity, r is also changing, and we already saw that u r cap vector also changes,
Yes,
right?
sir.
So you can write it as dr by dt into ur cap plus r into dur cap by dt. Understood?
Yes, sir.
So because both are variable, right? So it is a differentiation of two variable quantities. So we applied the chain rule, product rule.
Yes, yes, sir.
So dr by dt is called as this.
Omega.
No, no, we'll come to that. So this is called as along ur cap. So we'll call it as vr.
Okay,
First,
huh.
radial component of velocity. Okay.
Okay, yeah.
So
Sorry.
this is
Huh.
dr by dt. We will call vr, and plus r into, you know that dur cap vector is what we have just written, d theta into u theta cap, right? So
Yes,
I
sir.
will write it as d theta by dt into u theta cap. Correct? Because your dur was d theta into u theta. So d theta by dt into u theta cap. Is this clear?
Yes, sir.
So this quantity we'll call it as v theta. So we can write it as vr ur cap plus v theta u theta cap.
V theta.
Yeah, v theta means the direction of the velocity component along u theta cap. This is called axial component of velocity, and this is called radial component of velocity. This is called radial, and this is called axial. Okay. When the particle moves in circular motion, so in circular motion, what happens? Your radius vector is always constant. The magnitude of radius is always constant, right? In circular motion. So Vr will be equal to, Vr was what? Dr by dt. So dr by dt will be zero because r vector, r is always constant, not r vector, r magnitude is always constant. Understood? And v
Yes,
theta
sir.
is what? Nothing but r into d theta by dt. So r into d theta by dt, if you call it as omega, then v theta is omega. So in circular motion, you will see that the particle has only axial component of velocity, and in circular motion, axial direction is same as tangential direction. In general, it is not. That I'll explain. In general, axial direction is not same as tangential direction. Okay, but in circular motion, axial direction is the direction of u theta cap. So in circular motion, you will see that the direction of u theta cap is same as the tangential tau cap. So this is u theta cap, right? This is the direction of u theta cap. This is also the direction of tau cap. So you will have only velocity along u theta cap, which is v theta, and that is omega. There is no radial component of velocity in circular motion. But if you have a general motion like this, plane motion like this, okay, then any point of time, the velocity will have two components. One component of velocity will be along ur cap, which is like this, along ur cap, and one component of velocity will be along u theta cap, which is like this. Okay, and v this
Yes, sir.
Vr will be equal to dr by dt, and v theta will be equal to r into d theta by dt. This will do in circular motion. This you understood? Any doubt in this?
Yes, sir. No, no.
So always velocity will have two components, radial component and axial component. Radial component is dr by dt, axial component is r d theta by dt. In circular
Sir, should
motion,
I include this in the notes?
yeah, you can write it. Yeah. Okay.
Because it's like circular motion.
Yeah, we will again do it. I just gave you a background like how these things are useful. Okay.
Okay.
We'll anyway we'll do it in circular motion. But just for an example, you can write it where this is applied. Okay.
Okay.
So this is applicable there when we'll do circular motion. So that's why I'm telling the first two, three class, no, if you understood that, then it will be very easy going forward. Okay.
Yes, sir.
So your circular motion is almost like over. So and one more time you differentiate, you will get AR and A theta. So AR is
Ah,
called as the centripetal acceleration that I'll explain, and A theta is a tangential acceleration. So net acceleration, that is the circular motion. You can solve circular motion after
yes,
that.
sir.
So this thing you understood? How did it?
Ye-
How did I take differentiation? What is radial component? What is axial component? And in circular
Yes, sir.
motion, now there will not be any radial component. Only tangential component will be there. In planar motion, both the direction of velocity will be there. This you understood?
Yes, sir.
Okay. One last comment is dr vector dr by dt is different and dr by dt is different. Okay, are you getting me? Both are two different things. Understood?
Huh.
Vector dr, this is velocity vector. Dr vector by dt is velocity, net velocity. Okay.
Yes, sir.
Dr by dt is only Vr. It is only the radial component of velocity. So
Yes,
both
sir.
are two different things. Understood?
Yes, sir.
Similarly, we'll see that dv by dt is different. It is a net acceleration, but dv by dt is just tangential acceleration. Okay, this we'll see.
Yes, sir.
Read out so far.
No, sir.
Okay. So let me complete this at least polar coordinate. Okay, so you're okay now? We can extend this class.
Yes, sir. Yes, sir.
So yeah, so this polar coordinate is over. One more thing, let's write the length vector, differential length and differential area in polar coordinate. Okay, so okay, so how to write differential length? Differential length. Okay, in polar coordinate. So what I mean by this is the speed is okay.
Yes, sir.
So if this is your x coordinate, y coordinate, this is x coordinate, this is y coordinate. So if I choose, let's say any length like this along the radial direction, if this was your radial direction, so if I choose a length like this, okay, this kind of length means I will go to r comma theta, and this coordinate will be r plus dr comma theta. Okay,
Yes,
then
sir.
this length magnitude is how much? Dr. Okay, so this length I will call it as dr vector. Is dr is the magnitude and direction is along ur cap. So I'll write dr into ur cap. Is this clear?
Yes, sir.
If I choose a length like this, let's say, uh, so let's say if I choose my length like this, so what I'll do is at r I will go to theta plus d theta, like this kind of length. Okay, this kind of length. Are you getting me? So if this point coordinate was r comma theta, so this point's coordinate is r comma theta plus d theta. Understood?
Yes, sir. Huh.
So how much is this length? Magnitude of this
Uh, RD theta.
r d theta. So this time I will write dl vector as r d theta into u theta cap, because this direction is u theta, right? This direction is what direction? U theta cap.
Yes, sir.
It's very small. So dl vector I will write is r d theta into u theta. If you have a general length like this, so let's say if your coordinate system is like this, Okay, if you have a generic length, like what I mean is if you choose a length like this in general. Okay, so it seems to be vertical, it is not vertical, it is like this, let's say like this kind of length. Okay, so what I mean is that if this point was r comma theta, this point is r plus dr comma theta plus d theta, this kind of length if you choose.
Yes,
Okay,
sir.
so this kind of length is basically, this length is consist of this length plus this length, right? So basically
Huh.
you can write it as dr is dr into ur cap plus r d theta into u theta. Okay, any generic length you can write like this. Is this clear?
Huh. Yes, sir.
Any doubt in this?
Sir, could you tell that once again?
See what
That
I'm,
that one line.
any length along r is this, any length along u theta is this, right? This is dr into ur cap, and this is r d theta into u theta cap. So any generic length is a vector combination of this, these two, right?
Yes, sir.
Any generic length dl in this direction, I can write this length plus this length, vector combination of these two length.
Okay, yeah, yeah.
Right? So I can write r d theta into u theta cap plus dr into ur cap. Is this clear?
Yes, sir.
So this is the generic length we write in polar coordinate system. Otherwise, mostly we will use either this length or this length along ur cap or along u theta cap. Got it?
Yes, sir.
Now let us write. This is just in 2D. Now slowly we'll move to 3D. Okay. So let us write the area vector in polar coordinate. These things will be very useful in Gauss law and all. Okay. So area vector in polar coordinate. So how will you write area vector in polar coordinate? So let us assume that, okay, this is my x-axis, this is the y-axis. So I can, what kind of area I can choose? Only one area, and that area will choose it like this kind of area. Are you getting me?
Yes, sir.
So this is like I was at r theta and I went to some other r plus, like this is r theta. Then this point coordinate is r plus dr into theta, and this point coordinate is r comma theta plus d theta, and this point coordinate is r plus dr comma theta plus d theta. Understood?
Yes, sir.
So can you tell me what is this length? What will be this length?
Dr.
Dr. Very good. And what is this length?
RD theta.
RD. So what is the area magnitude? RD theta into dr, right? This is
Yes, sir.
very small, so you can assume it to be a square or rectangle, right? Not a square, rectangle. So dr into RD theta. This is the area of this thing. Is this clear?
Yes, sir.
And a unit vector perpendicular to that. So ds vector I call it this magnitude of the area, and a vector perpendicular to that will be along z axis. So I'll write k cap. Got it?
Ye- Yes, sir.
So this is the area vector in polar coordinate. Okay.
Got it, sir.
Mhm. Now, uh, one more thing is there will not be any volume thing in polar coordinate because it is two-dimensional figure, right? You cannot define a volume. Volume is defined for three-dimensional figure. Okay, so we will not do volume in polar coordinate. Okay, one thing I wanted to tell you is many situation, no, you will see that you will choose, this is a very small strip. Okay, many situation you will see that you will choose a finite strip like this. For example, if there is a semicircular disk or circular disk, then we'll choose our area vectors and all like this. So for example, I can choose my area vector like this kind of thing. I'll take a radius of small r, Let's say this bigger radius is capital R. Let's say this is capital R. Okay. And I will choose a small radius of R. So this circle is small r. Okay. And then I will go to R plus dr. I will go to R plus dr like this. I'll choose again a circle of radius R plus dr. Are you
And then
getting
you
it?
will cut it open, and then you will take the length as 2 pi r and
Yeah.
thickness as dr.
Correct. So that is what I am telling you. So this is small r and this is R plus dr. Okay. So the cut in between that you got this one. Okay.
Yes, sir.
So this area will be how much?
2 pi r into dr.
2 pi r into dr. Okay. So sometimes you choose your finite elemental area. This is called finite elemental area. Sometimes you also choose like this. So what you will do is you will go like this. Okay. So what you will do, you will go at any point here and theta, and you will go at theta plus d theta like this. Okay. So you will have a sector in between this area. Okay. Are you getting me?
Yes, sir.
This area. So what will be this area?
Rd theta.
Sector area is what?
No, that length will be
Yeah, so
Rd theta.
sector area, if sector area is, this angle is theta, this is r, then sector's area is half r square theta. Right? This you would have done in 10th class. So if this length is d theta, this area angle is d theta, then this sector area I can write half r square d theta. Understood?
Yes, sir.
So sometimes we choose this kind of area, sometimes we choose this kind of area. When to choose what, that is very important. Okay, that very few people have that understanding. So let me tell you here, let me see if you can understand, otherwise we can do it in Gauss law also. Okay, see, when we choose this area, no, let's say, when do we choose this kind of thing? Let's say your sigma is given, okay, like surface charge density or surface mass density is given. Okay, so this is very important, that whatever this is, we keep always this thing in mind that I'm going to write here. Whatever elemental area you are choosing, elemental area that is being chosen, okay, that is being chosen, you should always keep in mind that the sigma should be constant in that area. Sigma can be surface charge density or surface mass density. So sigma
Yeah, otherwise
should be
you'll
constant.
have to integrate and separate
Yeah,
this
should
thing.
be constant in that area. Okay, what I mean to say, that if let's say uh, sigma is given as 5 r square plus 3. Okay, one case sigma is given as this, and second case sigma is given as 2 cos theta plus 5. Okay,
Yes,
so
sir.
sigma is your surface charge density or surface mass density. Okay, so which case, which elemental area will you choose? See, first of all, firstly, this kind of thing you can always choose. Okay, r d theta into dr. But when you integrate, no, you will have a double integration. Okay, so double integration is also easy. That I'll tell you. So let's say I'll tell you, we'll do, let's by all the three methods. Let's do by method one. So by method one, I will choose a elemental area like this. Okay, so I can write the mass dm or dq charge is sigma into the area ds,
Yes,
right?
sir.
So in this case, I'll write, in the first case, I'll write it as 5 r square plus 3 into r d theta into dr, right? This is my area. Or in
Yes,
second
sir.
case, I'll write sigma into ds. So second case, sigma is my 2 cos theta plus 5 into r d theta into dr, right? And then if you have to integrate, so you have two variables, d theta and dr. So basically you separate the dr variable together. So I'll write 5 r square plus 3 into r into dr and into integral of d theta. And you individually you do both the integral and take the multiplication. Okay,
Sir,
so
can't we?
we can do that. Okay, for the time being, you assume we can do that. I'll show you the proof later. Okay, so whenever you have double integration, you can do. But double integration is not in your syllabus, but anyway it is the objective exam, so you can always do this. Nobody is going to check that what method you have followed. Okay.
Oh, you have to integrate like different these
Yeah,
things and you have to multiply
yeah,
it.
just multiply. So if you have to, let's say, complete the full circle, then r limit will be 0 to capital R, and theta limit will be 0 to 2 pi in case of circle. If it is a semicircle, and 0 to pi. If it is a sector, then 0 to that pi by 4 or whatever. Okay. And in this case also, you can do 2 cos theta plus 5 into d theta, and that integral you can do from 0 to 2 pi and into r dr, 0 to r.
But cos theta varies with every
Yeah.
quadrant, right?
Yeah, so that the cos theta d theta you integrate and put the limits, that will take care of that. Okay.
Okay. Yeah.
So this is the first method if you do this kind of differential elemental area. Okay. But you can do with finite elemental area also. Okay. But you have to be very careful. In this method, you don't have to worry that what kind of area you have to choose. You have always choose dr into r d theta. But if you choose with finite elemental area, you have to be very careful what area I am choosing. Let's say if you are choosing this thing for the first part, if you are choosing this area, then in this thing, this in this small area, this small area has r as constant, right? Because this area has r is same r is that r, small r, because you have gone to radius r and you have gone to r plus dr. So radius of this small strip is always r, right? This
Yes,
small
sir.
strip radius is r only, and sigma is,
DR, no?
no, radius is r.
Okay, okay, okay. Yeah. Uh-huh.
So radius of this strip is r, and sigma is a function of r. So at that r, sigma is constant. Sigma is not varying. So if you have taken this small strip, then you go to this point or this point, sigma is same because r is same, right? Are you
Okay.
getting me? But
Sir, I'm not able to get you like.
okay, let me explain. This is
Sir,
very
sir, I didn't take screenshot.
yeah, yeah. This page
I
is
didn't take.
yeah. Take
1 minute. Okay, yeah.
previous page you have taken. This page.
Yes, sir.
Okay. Yeah. So this thing is very important. Okay. So if you're not understanding, let me know. Don't compromise here because this is what we will apply everywhere. Okay. So what I was telling is that sigma that one thing was 5r square plus 3 and top 2 cos theta. Let's say sigma is 5r square plus 3. Okay. Another case sigma was 2 cos theta plus 5. Okay. So what I'm telling is that whatever elemental area you have chosen, in that area your sigma should be constant. Okay. So what I mean by that, like if you have gone to r and if you have gone to r plus dr. Okay. So in this strip you take any point. So this is your strip. You take this point or you take, let's say, this point. Okay. For both the points, sigma is same because r is same. Are you getting me? Are you there?
Yes, sir.
Yeah. So in this strip, you take any 2 point. You take a point here, you take a point here, and you take a point here. For both the point r is same, no, that is small r, right? Because this is the
Yes,
radius
sir.
of the strip. This is r plus dr. So both are same. R plus dr and r is almost same, right?
So we can consider R only.
R only, yeah. So any point on this strip, r is same, right?
Yes, sir.
R is same, then sigma is also same because sigma is a function of r only.
Okay, okay, yeah. Huh.
Okay. But suppose if sigma was this, not this, if sigma was this, but then if you choose these 2 point, thetas are different for these 2 point, right? This is the theta for this point, and this is the theta for this point.
Yes, sir.
So thetas are different. That means sigma for this point is different than sigma from this point. Are you
Okay,
getting me?
so we should choose according to.
Yeah, according to the configuration that is given. So you cannot, if this is the sigma, then if you are choosing an elemental area like this, it will be wrong. Are you getting me?
Got it, sir.
So you should choose an elemental area such that the sigma should be constant over that elemental area. Then only you can integrate. Are you getting me?
Yes, sir.
or then in this case what kind of area I have to choose? So in this case I told you that you have to choose an area like
You
this.
have to use an elemental strip because it can vary with theta.
Yeah, I'll show you. So basically in this case what you can do is, uh, so in this case if I use the area like this, so I'll go to theta and then I'll go to theta plus d theta. Okay, so now you consider this strip. You take any 2 points in this strip. So if I take any 2 point, let's say if I take this point and this point, right? R is different for these 2 points. This is R1 and this is R2. But theta is same for both this point, right?
Yes, sir.
Because theta and theta plus d theta, there is almost theta. Okay. So for this point P1 and this point P2, theta is same. So theta is same for P1 and P2. Same for P1 and P2. But R is different. R is different for P1 and P2. Are you getting me?
Yes, sir.
So in this case you have to choose this kind of area, because then over this complete strip, since theta is same, so sigma is same. So sigma should be constant over this strip that you have chosen. But if it was this, then you cannot choose this because R is different. So sigma will vary in this strip itself. R is
Yes,
different
sir.
for this 2 points. So in this strip, sigma will not be constant if this is the configuration. Are you getting me?
Yes, sir.
No? Huh? Hello?
Hello?
Yeah, did you get me 100% or?
Yes, sir. Yes, sir. I understood.
Okay. So based on the configuration, if you are choosing a finite elemental area, you have to see what kind of configuration it is. Okay. Whatever the
Yes,
key
sir.
is the elemental area that you choose, I have written here. Whatever elemental area you are choosing, sigma should be constant in that area.
Sir, what if sigma only is varying?
Sigma is varying. No, sigma is function of R or function of sigma. Sigma is varying, but in that small area, it is constant.
Okay. We should choose according to where it is constant.
Yeah, you choose an area, whatever area you choose, you take that area and verify that in that area sigma is constant.
Okay,
That
sir.
is the
So
configuration.
if
That is
sigma is given as
Hmm.
function of r and theta at the same time, then we'll use double integration.
Then there is no other way. It is double integration. Okay.
Okay. Yes,
So
sir.
most of the time you will in Europe there are questions are there like that, but most of the time since double integration is not in your syllabus, they will not give you where sigma is a function of r and theta both.
Like double integration is basically like integrate like respectively and multiply, right?
Yeah, just multiply. Yeah.
Okay.
It is easy. It is nothing like rocket science. But only thing is that you will do it in first year engineering. So it is not there
Oh,
in your syllabus. So
okay.
basically, they will not give you as a function where sigma is a function of r and theta both. Okay. If they
Yes,
give
sir.
you, then you have to choose r d theta into dr, that elemental area, and do double integration. Understood?
Yes, sir.
So this is a very important point because everywhere, whatever it is, electrostatics, gravitation, current, whatever, you have to choose elemental areas like that. So what elemental area you choose, you have to be very careful. Okay. So
Yes,
people
sir.
always choose this area. They don't know how when to choose this area. Okay, this area is also very useful. Sometimes you have to choose this area, but most of the question it will be only function of r. So they always know that okay, I always choose like this. It's not like that. Okay. It depends how sigma varies. Based on that, you have to choose your elemental area. Is this correct?
Yes,
Is
sir.
this clear?
Yes, sir.
Okay. So this is we
This
completed
is for polar coordinates.
polar coordinates. Yeah. Okay.
Okay.
Similarly, for yeah, let me discuss for rectangular coordinate. I didn't discuss that. So
Sir,
in
sir, sir, 1 minute. Yeah, sir.
okay. So for rectangular coordinate, it will be like similarly. Let's say if you have a strip like this, okay, and you have two ways. Let's say sigma is a function of x. Let's say it is 5x square plus 3, and sigma is a function of y, 5y square plus 3. Okay, then what kind of elemental area will you choose? There is two possibility. One thing is that you choose dx into dy, then double integration will come, right? So this area is
Yes, sir.
dx into dy. So it is sigma into dx into dy. So if sigma is a function of xy, you can integrate separately. Okay. Other
Huh.
method is you can choose elemental area like this. So what you can do is you can choose an elemental area like this,
And
right?
then separately do for X and then separately do for Y.
No, no, no. If when to choose this area, what my question is when to choose this area and when to choose this area, this area, small area.
We'll use a vertical area when it is given as function of X.
Yeah, correct. Because why? Because for vertical area, x is constant. Anywhere you go, x is same, right? Because this is x
Yeah.
and x plus dx, so that is almost x, right?
Yes, sir.
We will use this kind of stream when sigma is a function of x. You will use this kind of stream when sigma is a function of y. Because for this guy, y is same, y and y plus dy, right? So y is constant. So in this case, you will use this kind of strip. In this case, you will use this kind of strip.
Yes, sir.
Understood? So choosing your differential area is very important. If you are choosing a dx dy kind of thing, don't need to worry. If you are choosing a finite differential area, finite element, this is called finite element, and that is called this is called differential element. Understood?
Yes, sir.
This is called finite element method. Finite element method. Okay, and this is called differential element method. This one is called differential element method.
Sir,
Mm.
like in electrostatics, some cases come, right? Like when you consider a sphere,
Yeah,
like a small, this part of a sphere,
yeah,
then it'll look like an onion ring.
yeah.
Sir, that time what do you do?
I'll come to that. That will come under spherical coordinate system. Okay.
Ha
I
ha.
covered rectangular, I covered polar. Now next we'll move to cylindrical coordinate system. And then last is spherical coordinate system. So once you are done with all these four coordinate system, all shapes are covered. Okay. Any shape you have to find anything, electric field, this, that, potential, anything you can do. Okay.
Okay. Yes, sir.
So let me start with cylindrical coordinate system. I think I've covered everything. Area, length, this, yeah, I covered everything. If something I misses out, then we can cover it later. Okay. So let's move to cylindrical coordinate system. Okay.
Sir, I missed it again.
It's on this page.
Yeah. Sir, like, do you get like PDF? Can you make a PDF?
PDF, I think image we can save, and then I'll try that. I think it is getting saved as JPG, and
Yeah, for me also, like I can save directly, but every time you have to shift to pages, it'll be.
yeah, I'll
Oh,
see.
I saved it now anyway, but I'm
Mhm.
just telling.
Yeah, I'll see if I can convert into PDF. But you see, even if you are saving this, no, Rohit, what I will suggest you is that you make your own notes. Okay.
Yes, sir, I'll see this only and I'll make my own
Yeah,
notes.
yeah, you make your own notes. Don't depend on this because your notes you will one first advantage you will write yourself, right? So that will be kind of a revision. Okay. And second thing, last moment, no, when you will have exam 1 month away, that time your notes will be very useful for you. Okay.
Sir, like 1 month before exam, like how do we solve? Do we solve HC Verma or do we just see notes or what is
No,
the
1 month before you just see notes, and by the time you will your receive my Erudo, everything will be over. No, so from January onwards, you have to just write test as many as papers you can solve. Take any paper, just solve. You should be in that
sir,
mode.
but January first only is January first week only is test, right?
Yeah, yeah. So that's what I'm telling. So by January, your try to cover your syllabus by December. Okay. December, your physics you should try to cover, and then from October onwards, like you should start giving tests. Like parallelly, you should do. For example, by October, if let's say mechanics is over or mechanics and electro is over, then you should start writing tests. And join. You are in Akash, right, or Ellen?
Alan.
So Ellen test series will start. No, so try to
Yeah, they'll start by October because they'll finish portion by October.
yeah. So try to give test series and all.
Yes,
Okay, I
sir.
think this is April end, right? So Yeah, by October, November, I think we can cover most of it. Like mechanics, electro will be covered for sure. Maybe waves will be also get covered. Okay. It depends like how fast you solve. Okay.
Yes, sir.
My classes are like initially it takes time. First 10, 15 classes will take time. After that, it will be very fast. Okay.
Yes,
So
sir.
because once your foundations are set up, then you can do easily. So initial few classes, I have to set up the foundation, right? These coordinate systems and all. Nobody teaches that. So basically, these things takes time. And
Yes,
after
sir.
that,
Exactly. Even in Allen, vectors and all, they never even concentrated.
yeah. But that is the most fundamental thing. If you're not good in coordinate vector, then you'll be in trouble.
No, because like he didn't teach vectors, and then suddenly now we came to electrostatics. Suddenly there's so much use of vectors and integration of vectors and all of that.
Mm. Yeah, and one
And
more thing I wanted to ask you, why do you want to go to LN now?
sir,
Like you will be still going to LN, right? So why you do want to do class there and here also?
sir, I have to attend, right?
Yeah, but unnecessary you'll waste time, no?
Like it's an online thing, so I have to attend class from 2 to 7.
It is mandatory.
Yeah,
No, no.
because like
What I'm trying to say is that here I will teach you. Again, you will take those classes. So again, two different kind of things, right? So you will get confused unnecessarily. You will waste time. Rather, you can use that time to solve problems. Your wish, but I just my suggestion, like why to waste time two times?
yeah, but that will be only for physics, right?
Yeah. Similarly, you have math tuition also, right? You are doing math tuition, no?
Huh.
Yeah, so in all subjects, whichever subject you are taking personal tuition, so align with one person. That is what I'm telling. Don't do from multiple source. It will harm you. It will not benefit you. It will harm you. Okay, because
Sir, that's true, but like if I don't attend class, then they'll
then
not leave me alone.
you find out some way. That is, see, you will do electrostat from somebody. Again, I will teach you. Then you will get confused because you know something which is very different or some right. See the way I am teaching you, right? So coordinates and all, nobody has taught you. Then I will apply these things, but you know some different method. You will get confused. Finally, in exam you will be confused. Okay, I should apply this or that.
Yes, sir. I'll see what I can do.
Okay, so no need to waste time because you are already 1 year is very less time. Okay, so you have to
Yes,
use
sir.
1 hour of it. So don't waste. Don't think that okay, taking too much of classes will help you. It is your self study that will help you.
Yes,
Okay.
sir.
So the only thing is that my role or somebody's role is just to show you the concepts how to apply. Okay.
Yes, sir.
And then empower you to do. Then after that you have to do. So more self-study time you have to find. It should not happen that okay, full day is going in classes and coachings and all that. Because
Yes, sir.
when I used to study, we used to like do 8 hours, 10 hours self-study like that. Okay. So that kind of time you have to find for yourself.
Sir, you made it right, sir.
Yeah.
You made it to IIT.
Yeah, I was in IIT Kharagpur. Okay.
That's a dream college for many people.
Yeah, so that's what I will like. It requires a lot of dedication, particularly for 1 year. It is like you have just 1 year, so you have to find time for self study.
Yes, sir.
Okay, so don't waste time in multiple coaching classes. Is that if you see like yeah, don't take like what this is what my suggestion. You can discuss with your parents and this. The thing is that don't what I will suggest is don't do from multiple sources. Even books also. First stick to HC Verma. Just do HC Verma. Don't touch any other book.
Yes, sir.
Any other book, any other sources, LN material, nothing. Just complete SC Verma. Keep a target. Next 3 months, I have to complete SC Verma. Be on top
Okay.
of it. Complete SC Verma full, and then we'll come to Erodo. Okay.
Yes, sir.
So and don't touch any other book. Whatever books you have, people buy a lot of books. Okay, multiple books will be there. Just keep aside every book. Just keep SC Verma. That's it. And my notes.
Yes, sir. Sir, how did you do chemistry?
Chemistry I did like for different sources. For organic I did Solomon. Physical I did NCRT and RC Mukherjee. In organic I did little bit of and Jedli and NCRT. So like that. Okay.
Oh,
So physics is, see, physics, if you understood the concepts and all, it is a very, very easy subject. Where people find it very complicated because they don't do it in that way. Okay. And if you understood the concept, it doesn't require a lot of practice also. In maths, you need a lot of practice.
yes, sir.
Okay. And you have to balance all the subjects also. Okay. So it is a very difficult task which has to be achieved in within a year, but it is doable. It is not like it is not doable. It is doable. You need that dedication for 1 year. You have to forget everything and you have to do this for 1 year. Okay.
Yes, sir.
Yeah. So time is running, man. So we'll just start. I'll give you a background about cylindrical coordinate system. So cylindrical coordinate system. Okay. See, time now is the correct time that you should get serious. Okay, because after 4 months, if you realize no, by that time it will be game will be over. Okay. So this
Yes,
is
sir.
the correct time that you now get serious. Try to understand the importance of time. Where take a judicious call. Where should you spend your time? Okay, which is
Yes, sir.
good for you, and how much time you are getting for self study. So all those things are very important. Okay, it is like overall strategy you have to make and you have to follow it. And don't be too late in this. Okay, this is a very
Yes, sir.
right time that you are like April. Like we have a year almost for the next year advance. So this is the right time. Okay. Okay, so what I was telling you, cylindrical coordinate system, it is a three-dimensional coordinate system. Okay, so you have to be little bit, you have to focus here. So um, here, let's say there is any point P space, it is x comma y comma z. Okay, this is the position vector. Understood?
Yes, sir.
So I've already told you in rectangular coordinate system that if you drop a perpendicular, okay, and if you join this line, so this line will become this line, right? So this is the line on the plane. So if this was M, and then you drop a perpendicular here and a perpendicular here, right?
Yes, sir.
So this should also look like perpendicular. Okay. So this is M, this is let's say Q, and this is N. Okay. So I
Yes,
told
sir.
you that this distance is your X distance, right? So this distance is X, and this distance is nothing but Y, right? Got it? So
Huh.
this is X, this is Y, this
Yes,
was
sir. Yes, sir.
your Z, right?
Yes, sir.
So this is your Z coordinate. Okay. This is your rectangular coordinate system. Okay, but let's see what is cylindrical coordinate system. In cylindrical coordinate system, we write is a rho, phi, and Z. Okay, this G and this G is same. Like if there is a point, then you drop a perpendicular on Z axis. Okay, let's say this is R. So OR is your Z, and that Z in this coordinate and this coordinate is same. That is the perpendicular intercept on the Z axis. Is that clear?
Yes, sir.
Okay. Now, what is rho and what is phi? Okay. So rho is in cylindrical coordinate system. Rho is if you drop a perpendicular on xy plane, then this vector OM vector makes some angle with x-axis, right? This angle is called as phi.
Okay.
Okay. This is also called as angle of azimuth. Okay, latitude, longitude, all these things comes here. Okay, so anyway, we will not go into that. That is geography. So this phi is this angle, the angle that the perpendicular from P on xy plane, okay, that vector makes with x-axis, that angle is phi. Understood?
Yes, sir.
And this length of OM vector is called rho. Length of OM vector. Understood?
Okay.
This is called rho. Okay, and Z is Z. So now, can you tell me if somebody asks you that okay, the cylindrical coordinate system is 5 comma 30 degree. So let's say cylindrical coordinate system is 5 comma 30 degree. That is not right. So let's say this coordinate system somebody has given you 5 comma 30 degree comma 2. You convert into xyz. Okay. So see, from here I can write that x is equal to rho cos phi. Can I write?
Yes, sir.
And y is equal to rho sin phi. Can I write?
Yes, sir.
And z is z. Right.
Yes, sir.
So if it is
It'll be 5 cos 30,
yeah,
5 cos 5 sin 30
yeah,
and 2.
and 2. Okay. So this is how you can convert cylindrical coordinate system to rectangular coordinate system and vice versa. Okay. How will you convert
Yes, sir.
this to this from cylindrical to rectangular?
X
Rectangular.
by cos phi, y by sin phi.
Rho is what? Rho is your under root of x square plus y square, right? This square plus this square is rho.
Okay. Yeah,
And
yeah,
phi
yeah.
is and phi is your y by x, right? And z is z. So this is from rectangular you can convert to cylindrical, and by this you can convert from cylindrical to rectangular. Understood?
Yes, sir.
Now come to unit vectors. Okay. So here we define three unit vectors. One is u rho cap, u phi cap, and u z cap. Okay. Understood? What are those
Yes,
vectors?
sir.
Let us try to understand. Okay. So first vector is your
1
u.
minute or so. 1 minute, 1 minute, 1 minute. Okay, sir.
Okay. So u rho cap vector is a vector which is along this direction. Along row vector row was there, no, this om
Ha.
vector, yeah, along that vector we define u row cap. Understood?
Okay.
And a vector perpendicular to u row in the direction of increasing direction of phi is called u phi cap.
Yeah, just like polar coordinates.
Yeah, just so cylindrical coordinate in 2D is a polar coordinate basically. Okay, so this is your u phi. Understood?
Yes, sir.
Any doubt?
No, sir.
And a vector which is along z cap is your this vector k cap, because z is same. Okay, so this is your k cap vector. K cap vector will be along z cap, so it will be along this. Understood? So
Yes, sir.
u z cap is nothing but k cap. Okay, this is same. So no need to write u z cap also. You people just write k cap. So people do not even write u z k cap. They take euro cap, u phi k cap, and u k cap. But if somewhere if you see it is written as UZ cap, it is same.
Yes,
Understood?
sir.
So here also U row cap, so row vector, no, row vector is written as row into a unit vector along U row cap. Like there we were writing R vector, right? So R vector was R into UR cap. Here we'll write row vector as row vector is nothing but OM vector. Okay. So row
Ha.
vector is nothing but row into U row cap.
Yes, sir.
Understood? Now position vector is R. So position vector is nothing but OM vector plus MP vector, right? This is the
Yes,
position
sir.
vector. That is OP vector. OP vector is nothing but OM vector plus MP vector, right? From
Yes,
triangle
sir.
law. Are you getting me?
Ha.
Triangle law. This vector plus this vector is nothing but this vector, right?
Yes, sir.
Yeah. So OM vector is what? OM vector is
Uh,
nothing but rho into Euro cap vector, right? Just
ha. Yes, sir. Yes, sir.
MP vector is nothing but Z into K cap. Magnitude wise, it is Z. MP is
Z
nothing but.
into K cap. Ha. Yeah.
So this is what position vector in cylindrical coordinate system is written as R as. Position vector in cylindrical coordinate is written as, so R vector as rho u rho cap plus z k cap. This is very important. Understood? So
Yes,
in
sir.
cylindrical coordinate system, if I have to do velocity and all, then I will differentiate that. So velocity vector nothing but dr by dt. Will proceed from here. Okay. Now one more thing is that how to write du rho cap vector here, du phi cap vector here, and du z cap is 0, right? Because it is dk cap. Dk cap is 0 because k vector is fixed. But as the
Yes,
particle
sir.
euro vector will change. So euro vector was this. After some time, euro vector will be this. Okay. So based on the similar analogy that I have done, this is d phi. Okay. So you can write du rho vector as same thing, d phi into u phi cap.
Huh.
And
Yes,
similarly,
sir.
we will write here as the du phi vector as minus d phi into euro cap. Same thing that I have done in 2D. If you want me to explain here again, I can explain.
No, no, no. I got it.
So this is d phi. Okay. So basically, du rho cap vector will be in the direction of u phi. Okay. So this will be, let's say the particle was in the 2D, it was, if it is like this. Okay. So du rho cap vector will be along u phi cap, and this will be along du phi cap will be along this. So this is du phi cap, and this is du rho cap. Understood?
Yes, sir.
So these two things are very important: du rho cap and du phi cap. Okay, it is similar to that, but du z cap will be 0. Okay, so you can use
Huh.
find velocity. So velocity will be dr by dt. So you can write that as d rho by dt into euro cap plus euro cap into d rho by dt plus dz into k cap, dz by dt into k cap, right? This
Yes,
differentiation.
sir.
First thing, both are varying, so one by one I have to take. So d rho by dt into euro cap plus euro cap into d rho by dt, and this thing k cap is constant, so just dz by dt. Are
Huh.
you getting me?
Yes, sir.
Huh? So this thing, once you will write, so you will write it as d rho by dt into euro cap plus euro cap into, oh see, here I have written wrong. So this thing will be d rho by dt into euro cap plus rho into d euro cap by dt, right?
Huh. Yes, sir.
So d euro cap is what, d phi into u phi cap.
Huh.
Are you getting me or not?
Yes, sir. Yes, sir.
Yeah. So du phi, d euro cap is this, so I'll write rho d phi into u phi cap, d phi by dt into u phi cap plus dz by dt into k cap. Is this clear?
Huh.
So this we call
Yes,
it as
sir.
0 euro cap plus v phi u phi cap plus vz k cap, where v rho is nothing but d rho by dt, v phi is nothing but rho d phi by dt, and vz is nothing but dz by dt. Understood? So
Huh.
velocity at any point will have three components. One component will be, so let's say velocity, let's say the particle is moving in any trajectory like this in space.
Yes, sir.
Okay. So the velocity vector will be always tangential to the path, but it will have three components. One component will be along euro cap. So one component will be along this. One component will be along u phi cap, which will be along this, and one component will be along z cap, which will be along this. Understood?
Yes, sir.
So this is the velocity vector in 3D. So this will be v rho, this is v phi, and this is vz. Are you getting me? This 3D visualization you are getting in space.
Yes, sir.
The direction of v rho. This is the direction of v phi is going inward. Okay, this is the direction of v u phi going inward. This
Huh.
is v phi. Understood?
Yes, sir. Yes, sir.
Direction of v phi. Okay.
Yes, sir.
So this is the representation in cylindrical coordinate system. Now thing is pending is we will do elemental length in cylindrical coordinate system. Okay. Elemental area and elemental volume. Okay.
Huh.
So I'll just give you a food for thought. So you can write along y along rho axis. You can write d rho into euro cap. You can write dl vector as rho d phi into u phi cap, and dl vector along z axis you can write a dz k cap. Okay, and any arbitrary dl you can write combination of this. So dl vector you can write d rho into euro u phi cap, u rho cap. This is euro. Okay, d rho into euro cap plus rho d phi into u phi cap plus dz into k cap. Okay, this you understood, or I need to explain?
Sir, I'll see it once again.
Yeah, dl means along this, along the row
Huh.
direction. Dl.
Okay, yeah, I
D
got
phi
it.
is
I got
along
it.
this. This is rho d phi.
Huh.
This is rho d phi. This is d rho, and k cap is along this. The dz is along this. Okay,
Yes, sir. Yes,
dz
sir.
into k cap. Okay,
Huh.
if you go through that, you will get it. Okay.
Okay.
Similarly, we'll start from area in cylindrical coordinate system next class. Okay.
Okay.
So I think
Sir,
this will do spherical coordinate system. Then after that, once you do, no, you will feel easy. Okay. So as soon
after that, what will start, sir?
after that, we'll start kinematics.
Okay.
So after I finish a spherical coordinate system, then I will take your doubts on vector. Okay, vector chapter from HC Verma, and then we'll move kinematics.
Okay.
Okay, you have that book. Okay, leave. I think you just focus on HC Verma. Just buy Problems in Physics by I.A. Rodo. Okay,
Huh.
there is some 100 rupees books. Okay,
Yes, sir. Huh.
I'll
By
give
Arihan.
not Aryan. It is mere publication or something. Okay,
Okay. Okay.
so I'll give you problems from there. So I think kinematics will take 3 4 classes. So after that you can start solving. Okay,
Okay,
and
sir.
buy a question paper, question bank of last 20 years, chapter wise.
Okay.
Okay, like kinematics chapter wise it will be there. So that also you can know. So if you can do that parallelly, it will be very good.
Sir, if you now I can't buy, but
Yeah, now
if
you
you
are.
have,
Yeah, let the lockdown get over. I think after a few days you can buy. Anyway, we'll take some time to reach to kinematics. Okay.
yes, sir.
So first 2 chapters will take time. Okay. After that, it will be very fast. Okay.
Okay.
Okay. So you save this page.
I did, sir.
Okay. I'll see if I can convert into PDF. Just make sure you saved all the pages.
Sir, you're recording.
I think it got recorded. Yeah.
Okay, then, sir, because like I won't see the whole session, but some parts where I want to see again, it'll be really helpful if I could see
I
the
can send
recording.
it to you, but I think it will be a very large file, right? How to send?
That's why, sir, like I couldn't record it this time
Huh.
because you permission I require
No, no, but I
from.
recorded it. So, but how do I share the file?
If you share Gmail, it'll be faster.
Gmail, such a long file will not go. Let me check if with if I can share.
It'll come like a drive. It'll come like a Google Drive.
Okay, let me check that. Yeah.
Sir,
Okay.
just try, sir. If you can, you send. Otherwise, it's okay.
Sure, sure. Yeah.
Okay, sir.
You send me a mail to this email ID. Okay, your mail ID. So I will communicate through that. So it is goutam.iitkgp04 @gmail.com.
Okay.
Okay,
One
goutam
minute.
dot iitkgp
Yes,
04.
sir.
This is not 0404.
Huh.
Okay, you send me a test mail. I will send all the documents whatever we'll do in the class through that. Okay.
Okay. Yes, sir.
Okay. Bye. Rohit. Yeah. See you.
Bye, sir. Sir,
Huh.
when will we have class again?
Class again. Uh, okay, I'll let you know when are you free?
Uh, on Wednesday and on weekends.
Okay, I think weekend will be very long. So let me at least cover till kinematics. Then I think you can do problems, right? So we'll try to
Huh.
do Wednesday so that if I can cover spherical coordinate system, no, and kinematic, I want to cover till kinematics. Then you will have a lot of stuff to do at home.
Yes, sir. Yes, sir.
Okay, so we'll try on Wednesday. Okay,
Yes, sir.
okay, bye.
Bye, sir.